Okay, composite functions. SQA Higher Maths 2017, paper 1, question 1. F and g are defined as f of x is 5x, g of x is 2 cos x. Evaluate f of g of 0. Okay, there's a couple ways you can do this. You can find f of g of x, or you can work out g of 0 and shove it into f. I'm going to do it by doing f of g of x. So f of g of x is equal to f of 2 cos x. So every time I see an x in f, I put 2 cos x. So that means I've got 5 times 2 cos x, which is 10 cos x. And therefore, f of g of 0, subbing 0 into this, you get 10 times the cos of 0. The cos of 0 is 1, so that means you've got 10 times 1, which is just 10. And we're done there. Find an expression for g of f of x for part B. So g of f of x means every time I see a function in g, I write f of x, which is 5x. So it's g of 5x. And g is 2 cos x, so that's 2 cos 5x. And we're done there. SQA Higher Maths 2017, paper 1, question 2. This point P lies on this circle. Find the equation of a tangent at P. So I've already drawn a picture. P could be going about here, minus 2, 1. And a tangent makes a radius at right angles. So if I knew the centre, then I could find the gradient of the centre and use perpendicular gradients. And then y minus b equals mx minus a. Now, from the start of the exam paper, you're given this formula. X squared plus y squared plus 2gx plus 2fx plus c equals 0. And then the centre, that's the big C here, is minus g minus f. And the radius is g squared plus f squared minus c, c being in here. So 2g is the number in front of x, so 2g is minus 8. And 2f is the number in front of y, which is minus 6. So g is minus 4 and f is minus 3. So our centre is 4, 3. Let's call that our centre. Now we can do the gradient between c and p. So that's 3 minus 1 over 4 minus minus 2. That is 2 over 6, which is 1/3. So the gradient of our perpendicular must be minus 3, since m1 times m2 equals minus 1. And the point we've got is minus 2, 1. So y minus b equals mx minus a, so plus 2. So y minus 1 minus 3x minus 6. So y equals minus 3x minus 5. And that's the equation of our tangent. Chain rule. SQA Higher Maths 2017, paper 1, question 3. Y equals 4x minus 1 to the 12. Find the y by dx. Nice and simple. 12 down to the front. 4x minus 1. Take away 1 for the power, but then times the bit in the bracket differentiated, in other words, times 4. 4 times 12 is 48. 4x minus 1 to the 11. Job done. Okay, the discriminant SQA Higher Maths 2017, paper 1, question 4. Find the value of k for which the equation x squared plus 4x plus k minus 5 has equal roots. So for equal roots, we should know that b squared minus 4ac equals 0. So let's just use that. So our a is 1, the number in front of x squared. Our b is 4, the number in front of x. And our c is what's on the end, k minus 5. So b squared is 4 squared minus 4 times 1 times k minus 5 equals 0. So that's 16 minus 4 times k minus 5. So that's 16 minus 4k plus 20. Minus times a minus is a plus. 16 plus 20, so we get minus 4k plus 36 equals 0. Taking the 4k over, we get 4k is 36, and therefore k equals 9, because 4 times 9 is 36. SQA Higher Maths 2017, paper 1, question 5. Vectors u and v are 5, 1, minus 1, and 3, minus 8, 6. find u dot v. So start of the exam paper, u dot v, there's two things it tells you. It tells you to times the components together, or it tells you there's using an angle. And there's no angle here, so I'm just timesing the components. So for part A, u dot v, that's just equal to 5 times 3, the top numbers, plus 1 times minus 8, the second numbers, plus minus 1 times 6. So working out these, being careful of our negatives, 5 times 3 is 15, 1 times minus 8 is minus 8, minus 1 times 6 is minus 6, 8 and 6 is 14, so that equals 1. And we're done there. Part B says the vector w makes an angle of pi over 3 with u, and the size of w of the modulus is root 3. Find u dot w. So again, the start of the exam paper tells you that a dot b equals the size of a, size of b, cos theta, angle in between. So that means that u dot w equals the size of u, the size of w, times the cos of the angle. Well, we have the size of w, but we don't have the size of u. So we have the size of w, but not the size of u, but we've got u in part 1, 5, 1 minus 1. So a reminder, the size of u is just like Pythagoras, well, it is Pythagoras. So it's 5 squared plus 1 squared plus minus 1 squared. And that's National 5, that's it actually. So that is 25 plus 1 is 26, 27. I'll just leave it as a root. So that means that our u dot w is equal to the size of u, root 27, times the size of w, which is root 3, times the cos of theta, but the angle is pi over 3. So this is going to use exact values. 3 times 27 is 81. So that is the square root of 81. And then we need to find the cos of pi over 3. So I always think in degrees, personally. 180 divided by 3 is 60. So this gives me my exact value triangle of 60 and 30 degrees. And we've got 2, 1, and root 3. So we're looking for the cos of 60. So that is adjacent over hypotenuse. So that's a half. So that's root 81 times 1/2. That's 9 times a half, or 9 halves. And we're done there. Inverse functions SQA Higher Maths 2017, paper 1, question 6. The function h is defined as x cubed plus 7. Determine the expression for the inverse function of h. So I can just write y equals x cubed plus 7. And make x the subject. So that means that x cubed is y minus 7. So x is the cube root of y minus 7. And therefore the inverse function of h is equal to the cube root of x minus 7. Again, do not be tempted to write at this stage y equals the cube root of x minus 7 or you'll lose a mark because y is this and not that. So just watch a little bit of notational thing there. SQA Higher Maths 2017, paper 1, question 7. A, B, and C are vertices of a triangle. Find the equation of the median through C. So let me just draw a quick sketch. Again, I'm not actually trying to make this accurate, so I'm just going to write A, B, C in a clockwise rotation. And it says the median through C, so that's the line that cuts this in half. So I need the gradient, the midpoint of A and B, sorry. So the mid of A and B, well, that is equal to, we just add minus 3 and 7 and divide by 2, and we add 5 and 9 and divide by 2. So that is equal to 7 minus 3 is 4, divided by 2 is 2, and 5 and 9 is 14, divided by 2 is 7. So we've got our midpoint. So we now need the gradient between B and C. And now, M and... So we now need the gradient between our midpoint, let's call it M and C. So that's M, and remember C was equal to 211. Now, there's two ways to do this. You can either realise that since they're both along 2, that means that the lines are going to be vertical. Now, if you don't realise that, do the gradient anyway. So the gradient of M and C is equal to y2 minus y1 over x2 minus x1. If you ever get this happening with a 0 on the bottom, 11 minus 7 is 4 over 0, that means the gradient is undefined. Which means we have a vertical line. if you ever get a gradient of 0 and I was 0 on the top, it's got a horizontal line. So therefore, the equation of the median is simply equal to x equals 2. Now, you could have done that straight away just by realising that you've got 2, 7, 2, 11. So therefore, the x coordinate's the same, so x equals 2 is the equation straight line. But maybe it's best to do the gradient just in case. Hi, Maths 2017, paper 1, question 8 on differentiating a polynomial. Calculate the rate of change of d of t is equal to 1 over 2t. So we need to get it ready to differentiate. Always need to do that. So d of t is equal to 1 over 2t to the minus 1. Do not be tempted to move this 2. That's just a half still. Separate it out, it's just the t that's moving. Once we do that, d dash t, take the minus 1 down, so we get minus a half t, take away 1 from the power, we get minus 2, and we have to work it out when t is 5, so d slash 5 is equal to minus a half times 5 to the minus 2, or minus 1 over 2 times 5 squared minus 1 over 2 times 5 squared is 50. So minus a 50th. Just a note, remember rate of change means differentiate. SQA Higher Maths, 2017 paper 1 question 9 on recurrence relationships and limits. So a sequence is generated by the recurrence relationship un plus 1 equals mun plus 6 and m is a constant, a number. Given that u1 is 28, u2 is 13, find m. So we're just substituting in. So for part A, we know that u2 is equal to m times the one before u1 plus 6. So u2 is 13 equals 28m plus 6. Simple equation to solve. Take away 6 for both sides. 13 minus 6 is 7 equals 28m. And therefore m is 7 over 28. Simplify all fractions, we get a quarter. Part B1. Explain why this sequence approaches a limit as n goes to infinity. Well, that m is the number in front of un, so all we need to do is realise that minus 1 is less than a quarter, is less than 1, therefore the limit exists. And that's it, simple as that. Part 2 says calculate this limit. So to find the limit is b over 1 minus a. So b is our n number, which is 6. So we've got 6 over 1 minus a quarter, which is our first number. So that's 6 over 3 quarters. 6 divided by 3 quarters is the same as 6 times 4 over 3. 6 divided by 3 is 2 times 4. That gives me 8. The limit is 8. Find the area. SQA Higher Maths 2017 paper 1 question 10. Two curves with equation x cubed minus 4x squared plus 3x plus 1 and x squared minus 3x. Add 1, intersect in a diagram. Calculate the shaded area. To do shaded area between two curves, it's the upper curve minus the lower curve between the x's, which is 0 and 2. So I can immediately write down it is the integral between 0 and 2 of our upper curve minus our lower curve dx. So we can tidy that up before we integrate. 0 and 2, we've only got an x cubed term, and then our x squared, 4 minus 1 is minus 5x squared. Our x terms, 3x minus 3x is plus 6x, watch the signs, and then 1 minus 1 is 0. So we get this integral to do. So that is x to the 4 over 4 minus 5x cubed over 3 plus 6x squared over 2 between 0 and 2. That's x to the 4 over 4 minus 5x cubed over 3 plus 3x squared between 0 and 2. So we can now substitute our numbers in. So that gives us 2 to the 4 over 4 minus 5 times 2 cubed over 3 plus 3 times 2 squared. There's our first bracket. Minus, and it should be clear that it's going to be 0, but just for the sake of completeness, 0 to 4 over 4 minus 5 times 0 cubed over 3 plus 3 times 0 squared. All that stuff separately as 0. So we're just left with our top bracket. 2 2s is 4 times 2 is 8 times 2 is 16. Divided by 4 is 4 for our first term. Second term, 2 cubed is 8. 8 5s is 40. So we get minus 40 over 3. And 2 squared is 4 times 3 is 12. Tidying that up, we get 16 minus 40 over 3. Non-calculator, easiest way to deal with that is mixed numbers, I would say, because 3 times 13 is 39, so minus 13 and a third. 16 minus 13 is 3, minus an extra third is 2 2/3. And we're done there. Part B of this says the line passing through the points of intersection of the curves has the equation y equals 1 minus x. What fraction of the shaded area lies below the line? So we need to work out what the integral is below the line and see what fraction of the whole that is. You should be able to guess what the answer should be just by looking at it, but you can't guess. You have to do it. So we're doing the integral of between 0 and 2. Our upper function is the line this time, so 1 minus x. Take away. The curve below the line is x squared minus 3x plus 1. dx. Alternatively, you could have done this minus a line and then with a fraction left over to make a complete whole. It's your choice. I'm going to do it this way. So that gives me the integral between 0 and 2 of 1 minus 1 is 0. I've got minus x minus 3x. So that's 3x minus x is 2x. Then I've got minus x squared as well. So you get 2x minus x squared, a nice simple function to integrate. So that gives you 2x squared over 2 minus x cubed over 3. Between 0 and 2, that gives you x squared minus x cubed over 3. Between 0 and 2. So substituting 0 in, we get 2 squared, 2 in, so we get 2 squared minus 2 cubed over 3. Take away 0 squared minus 0 cubed over 3. That gives me 4 minus 8/3. That's 4 minus 2 2/3. That is 4 minus 2 is 2. Take away 2/3 is 1/3. So 1 1/3. But if you go back to our original question, the total area was 2 2/3. Remember, our total area was equal to 2 2/3. It should be obvious that that is a half. So therefore, a half of the area is below the line. And we're done there. Higher Maths 2017 Paper 1 Question 11. A and B are points, these here. AB is parallel to this line. Find the value of A. So parallel means same gradient. So if we look at 3y minus 2x equals 4, that means that 3y equals 2x plus 4. So y is equal to 2/3 of x plus 4/3. Key point is our gradient is equal to 2/3 because it's parallel to this line. And then we've got our points here, but we know if we use a gradient form on that, we need to get an answer of 2/3. So y2 minus y1 over x2 minus x1. So I'm going to do a take away 2 on the top and 5 take away minus 7 on the bottom, but that equals 2/3. Save it, 3 times a minus 2 equals 2 times 12. So 3a minus 6 is equal to 24. Nice and simple to solve. We get 30 and a is 10 for our final mark. Solving logarithmic equations, SQA Higher Maths 2017 Paper 1 Question 12. Given log a 36 minus log a 4 equals a half, find the value of a. So these are rules of logs to combine the logs. So that can give me log base a, and we've got 36 divided by 4 because of a minus equals 1/2. So log base a, 36 divided by 4 is 9, equals a half. So eliminating the log, a to the power of a half equals 9. a to the half equals 9. So that means the square root of a, we could write that, I suppose, equals 9. So if I square both sides, a equals 81. And we're done there. Okay, integrating with the chain rule, not a trig function, this one. 2017, paper 1, question 13. Integrate this function, so we need to get it ready to integrate first. So that becomes the integral of 5 minus 4x to the minus a half dx. It's telling you obviously that x can't be less than 5 over 4 because this would be not valid. Now, let's integrate that. So we add 1 to the power. So we get 5 minus 4x to the power of a half. We divide by the new power. So we divide by a half. But we also divide by the function differentiated. So times minus 4 on the bottom as well. And we've also got plus c, of course. So that gives me 5 minus 4x to the half. A half times minus 4, well, minus 4 divided by 2 is minus 2, plus c, tidying that up, put my minus on top, that gives me minus a half of 5 minus 4x to the half. With the functions, SQ Higher Maths 2017, paper 1, question 14. First part was a trig question, and then it moved on to having to draw a graph. So for part A, using our knowledge of trig, we have got root 3 sine x minus cos x. And we have to write it in the form k sine x minus a. So we expand that using the formula sheet. That's k sine x cos a minus k cos x sine a. Okay, so then we just equate the parts to each other. So if we look at the sine x first of all, we've got k sine x cos a, so that means that k cos a equals root 3. So I can just write that, k cos a equals root 3. And similarly, looking at the cos x part, which is over here, we've got minus k sine a equals minus 1. So we can just write k sine a equals 1. K sine a equals 1. So that means that our k, because sine squared x plus cos squared x equals 1, gives us the square root of root 3 squared plus 1 squared. So that is the square root of 3 plus 1, which is the square root of 4, which is 2. So our k equals 2. And then to get your a, so to get our a, remember sine divided by cos is tan, so I can write tan a is equal to the sine, which is 1 over the cos, which is root 3. So that's an exact value for tan a, because we've got a right angle triangle, and if you had 60 here and 30 here, you would have 2, 1 and root 3. So the tan of 30 is 1 over root 3. We need to use a cast diagram just to confirm. So if we look at our cast diagram, we need to check our original functions. Cos was positive, so that would be these two. And sine was positive, that would be these two. So yes, we're in the first quadrant, because we've got 2 ticks in A. So that means I can just say, therefore, A equals 30 degrees. And then our final answer is 2 sine x minus 30 degrees. And we're done there. So for part B, we have to draw the graph, but we've already put it in this form. So we're just going to draw the graph of y equals 2 sine x minus 30. So I know my amplitude is 2, so it's going to go between 2 and minus 2. And minus 30 tells me that it's shifted to the right by 30 degrees. So drawing a nice sketch of that, I can note on the y-axis the points 2 and minus 2. And then we're going to start at 30 degrees because we've shifted along. So we can just start drawing our graph and stop about there because it only goes up to 360. We can note our turning point. So normally it goes along to 90, but shifted to the right by 30 means that this point is 120. So 122. And similarly, this is usually 270 on a sine graph, so an extra 30 makes 300. So we've got 302. The other thing we could do is make sure you go back to 0, so you have to draw what's going to happen here. So it's just going to continue. We could notice where it cuts the y-axis. So it's going to cut the y-axis here, which is when x is 0. If you put 0 into this, you get the sine of minus 30, which is minus a half, times 2 is minus 1. So you could note minus 1 there. And there you go, you've drawn a sketch of the graph. You could tidy that up a little bit. We move on to what I would say is unusual differentiation questions. The first one we're going to look at, this stuff that doesn't come up as often, is this one. A quadratic function is defined on a set of real numbers. This was 2017, paper 1, question 15. Diagram 1 shows the graph of y equals f of x with the turning point at 2, 3. And diagram 2 over here shows the graph of h of x, and the turning point is now 7, 6. Okay, let's see what it's asking us to do. Part A. Given that h of x is f of x plus a plus b, write down the values of a and b. So in other words, it's a graph transformation question for part A. So let's have a look to see what's happened. If we look at this point 3, well, let's just look at the turning point. 2, 3, it's clearly moved along to become 7. 2's become 7, it's moved to the right by 5. So if it's moved to the right, then a must be negative. So a is negative 5 because it's moved to the right by 5. If n or b, well, plus b on the end means it's moved. The whole thing's moved up by some number. We started at 3 and we've ended up at 6. 3 plus 3 is 6, so b is simply the number 3. And we're done there. So part B says it is known that the integral between 1 and 3 of f of x is 4. What is the value between 8 and 6 of h of x? Well, an integral means an area. So we know that the area under this bit here is 4. So that means over in this graph, since it's just moved up, this whole area here is also 4. And leaving the extra bit between 6 and 8 is just a rectangle. That is 2 along. And that must be 3 because the graph's moved up by 3. 2 times 3 equals 6, so our integral between 8 and 6 of h of x is just 6 plus 4, which equals 10, and we're done there. Part C says, given that f-1 equals 6, what's h-8? f-1 equals 6, let's just use a different colour pen now. That means that the gradient of the tangent at this point here equals 6, and it's asking us, what is the gradient of the tangent at 8? Well, at 8 on h of x, 8 is this bit here. Now that's, if we imagine looking at this graph instead, that would be this point here. It's a mirror of this, so it's sloping down the way. So it's just minus 6, because it's just the other side of the graph. So h dash of 8 equals minus 6, and we're done there.